The increasing complexity of the state of the art deep learning models presents significant challenges not only in terms of computational demand but also in terms of memory and communication bandwidth. As these demands exceed the capacity of consumer grade GPUs, training larger models require innovative solutions. A prominent example for fine-tuning model is low-rank adaptation that uses a low-rank parameterization of a deep neural network to reduce memory requirements for storing optimizer state and a gradient communication during training. The memory requirement was further reduced by quantizing model parameters. Such innovations have enabled the fine-tuning of large models even on a single consumer-grade GPU. But the thing is that the previous work has been limited to fine tuning, and tools to pre train models from scratch are still not there. That is why the goal of this paper is to extend adaptation method to model pre training. Specifically, they ask the question, can neural networks be trained from scratch using low rank adapters? And that's a very important question. Successfully addressing this question carries substantial implications, especially considering that common computing clusters often have slower cross node training than single node training with gradient accumulation due to slow communication speed and bandwidth. Low rack adapters effectively compress the communication between these processors while preserving essential structure attributes for effective model training. Their investigation reveals that while vanilla LoRa underperforms in training a model from scratch, the use of parallel low rack updates can bridge this performance gap. That is where they propose this LoRa the Explorer, which is an optimization algorithm that can match the performance of standard training from the scratch. And there are a lot of good things around it. And this is the architectural diagram of it, which is quite simple, as you can see in this diagram for this LoRa the Explorer. This method optimizes unique LoRa parameters in parallel and merges them back to the main weights. This algorithm can leverage lower memory devices and only depends on communicating the LoRa parameters for training, making it an ideal candidate in a band limited or memory constrained training framework. Now, this is a really novel optimization algorithm because this is extending low rank adaptation method to the pre-training of neural network, aiming to address the computational, memory and communication limitations faced by current deep learning model scalability. Really hats off to all of these researchers who have done wonderful work on this one because this is a need of our. Because by enabling this parallel training of multiple low rank heads across computing nodes with minimal need for synchronization, this can go a long way because this LoRa the Explorer or LTE in short offers a solution for efficient model training on lower memory devices and in bandwidth constrained environments. That's it guys. I will drop the link to this paper in video's description. Read through it. Let me know what do you think. If you like the content, then please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.